Okay, let's see what we got. Maximum subarray sum with length divisible by k. We've done this. You give an integer array nums of an integer k. Return the maximum sum of the subarray nums such that the size of the subarray is divisible by k. So the size of the array is divisible by 1. The maximum sum. So I mean, you can just use all the values because that's length is 2 and this is divisible by 1. Okay. Oh, the numbers can be negative. I see. So so it has to be 4 length. So the smallest 4 length sum would not include the negative 5, which is big negative. So it'd be negative 10. I guess it can't be 0, right? The subarray can't be 0. Size, because it could be, if it could be 0, then you would choose 0. Because 0 is divisible by 4, no? Maximum subarray is such that the size is 0. Alright, well anyways, I guess ignore 0 as a possibility. So here 2 or 4 are the possible sizes. So it's probably the 1, 2. No, that's right, 1, 2, negative 3, 4. 3 plus 1, so that's 4. Okay. Maximum subarray. But it could be negative. Interesting. One first thought that comes to mind would be to kind of readjust it so that shifts all the negative numbers to be positive numbers, or finds the lowest number and makes that kind of 0 in the array, and then shifts everything up by the lowest value. So then you're strictly increasing your subarray sum if you were to increase the length. Does that make sense? To try to, so what would happen here? Be shifting negative 1, negative 2, negative 3, negative 4, negative 5 to become adding 5 to everything, I guess. So it'd be 4, 3, 2, 1, 0. So then you want something that's 4 length, and that would be this 4. Yeah. Otherwise, if you use the default valuation of these things, then it's not always strictly better to have a longer subarray, but if you kind of readjust it to remove negatives, then a longer subarray is going to be strictly better. I guess I could readjust it to 1, so it's 1 or 0 is fine. Alright, I'll do that real quick. I would like to be sure that a longer subarray is better. Is that correct though? Is that logic correct? So is that logic correct? Logic cannot be correct, right? Because there should be solutions where you want to choose a strictly smaller amount rather than a strictly larger amount. Yeah, so if this was 2, k is 2, I wouldn't want to choose all these values. Yes, actually, so it readjusts it, but then I would need to subtract the min value back from it, from the subarray sum. Min value times the length, or something like that. Okay, that's just not gonna work then. Not gonna work. So, what to do, what to do? It's almost like a sliding window problem. Window size has to be the length. Interesting. Size is the length. What if I group them by k? I find subarray sums of length k for each index, the sum of the next k elements. So like k is 2, so I do like -5 plus 1. Let's go ahead and just -5, 1, 2, -3, 4. So it's sum of the next two would be -4, -5 plus 1, 1 plus 2 is 3, 2 plus -3 is -1, -3 plus 4 is 1. And it would be something like -4 is a possibility, or -4 plus -1 is a possibility. Because k being 2, -4 plus -1 is going to be adding the first two and then adding the third and fourth. First two, third and fourth. So -5 is a possibility, 3 is a possibility, 3 plus 1 is a possibility. 3 plus 1 obviously is the winner. Interesting. Wonder if that's any faster. Wonder if you could just do that with sliding window somehow. In any case, it would be, how big is k? 2 to the 10th. 2 times 10 to the 5th. That's a lot of k values. 20,000. No, 200,000. K can be, yeah, 200,000. I was thinking about making buckets somehow, but it's probably not gonna work. 200,000. The maximum sum subarray. Where k is divisible. K, or the length is divisible by k. So if I do use a sliding window, how do I know how far to slide, I guess, is the question. 1, -3. I mean, I guess maybe I can do binary search way. Binary search way. Maximum sum in the subarray maximum's length is equal to 4 to... No, binary search is not going to work because you don't... maybe it would work. So you guess a value that is what the maximum value would be, and then you would just extend out the window until it works. But how do you know where the window starts, I guess? Yeah, you don't really know where the window starts. So if I guess it's possible to get a maximum sum that's 1,000. A maximum sum that's 1,000. Where k is 2. Then I look at every possible don't see it. Thousand phase 2. Then you extend out the window. Extend. Interesting. So it's always better to have a longer thing as long as your negatives don't get in the way, right? As long as your negatives don't get in the way. So the main thing is actually trying to figure out where the negatives kind of conflict with the longer thing. Yeah, interesting. So if k is 2, and let's say we have a 1,000 length array, you would in theory want all 1,000 elements if it was non-negative, because then that's just a bigger sum. But the reason why you wouldn't include like a particular portion of the array is if it's like a big negative number. And the benefit to including that kind of negative portion is the gain that you might have for the blocks of 2 that is after it that you would include, that you could possibly include. So as long as the blocks that you would be missing out on adds more to the sum than the negative block that you're considering, then you would include the negative block. Okay. And obviously if it starts with negative blocks, then you skip to the first positive block. First block of K. Yeah, so like 3, so it'd be 3, and then you consider 1. I think what I need is a way to compare. Let's say there's like 3, there's a couple more. Let's say it's like, let's say this is -1, 5, and 6, something like that. K is 2. So 3 considers whether or not to add a -1 block, and it would because 6 is there. And so I think I need something where I compare this -1 to all the blocks, the sum of kind of a prefix or postfix suffix sum array, where the suffix sum array has the sum of stuff after it at k distance away each time. Okay, I think yeah. Don't recall using this way or using this method before. But then I often don't recall how to do things consistently. So let's say I have subarray sums, and this is going to be an array for each index, a sum of k values starting at that index. So if k is 2, then it's like at index 0, it's the sum of 0 plus 1 values. If k is 1, or if the index is 1, it's the sum of the values at index 1 and 2, so on and so forth. So I think I just need a sliding window for that. Say the current sum is going to be 0. What's the current sum? It should be the sum of the maybe first k minus 1 values. Sum of numbers. Let's say current sum is 0 for index and range of k or k minus 1. So I think this should be k is 2, then it should be k minus 1. Current plus equals the value at this index. And then this is kind of sliding window to create the subarray sums. So for every index in range of k, or it might be k minus 1, k minus 1 to the length of the array, n equals length of nums. So up to n. So I add the current value to complete the current subarray sums. So index or current is going to increase by nums at index. That completes the subarray sums. Then I do subarray sums, append this current sum value, and then I remove the front of the subarray. So current minus equals nums at index minus k minus 1. So if the k is 2, it needs to remove k is 2, then adds index 1. That completes the subarray 0 to 1. then it needs to remove the value index 0, so case 2, so it's 2 minus 1. 1 is index 1 minus 2 minus 1. No, 1 minus 2 is like, actually, it's like this. It should be like that. Index, which simplifies to be index minus k plus 1. Yeah, I think that's right. Okay, I'm just going to print out the subarray sum. So the sum of the first two here is going to be negative 4, 1, 2 is going to be 3, yeah. Sum of the first 4 is going to be negative 10, second 4 is going to be negative 14. Okay, so subarray sum is fine, and then I want to do kind of a prefix sum here, or suffix sum. So the length of this should be, I want to go backwards. Guess I could go, yeah, I think I want to go backwards to create this. I don't know how long it should be though. This should be the same length as the subarray sum, so S length is going to be, or sub length is going to be length of subarray sums. And then this is going to be a suffix. It's going to be, I'll say 0 times the sub length. And then traversing backwards through the subarrays. This should be sub length minus 1, negative 1, negative 1. And this should do something like should take the previous total at index plus k and add it with the current subarray total at index. Think. I guess actually in that case maybe I do want it to be just the length of the original array so that I'll go out of bounds with this reference. So yeah, the suffix sum at the index is equal to subarray sums at this index plus suffix sum at index plus k. Okay, let's go ahead and see if that. So this is going to go out of bounds. Index plus k. That should work. Maybe it should be index plus k minus 1. So this thing was originally giving me this one. It was like a 2-length subarray sums. So 2 plus 4 is going to give me 6. So maybe I need suffixes n plus 1. It's not right. Sub length is 2. sublength is 2. Sublength, so 1. 1 plus 4 is 1 plus 4 is 5, and the length of the thing is 5. Why did it go out of bounds actually? Suffix at index. Subarrays at index. Subarrays at index would be subarray at 1. Okay, let's go ahead and print out indexes crashing on. Assume this is index 1 that's crashing on. Huh. Okay, let's go ahead and print out the suffix as well. This should be giving a 5. It's giving 2. It's giving 2. Index is 1. Wait. That should be index 0. What's going on? Sublength. Sublength is 2. Sublength should be... I see. Sublength is 2, yeah. Index plus k minus 1. Index is 1. One plus 1 minus 1. I think maybe, yeah, this might be index plus k minus 1. Yeah, it's not inclusive of the last index, right? Okay, so that stopped crashing. Okay, so -4. So backwards traversal here, this is just a dummy 0. This is 1. This is -1. That doesn't seem right. It should have been -1 there, to be honest. And this should have been like 4. 3 plus 1 maybe? 1. Yeah, it should be 1. Should be -1. K is 2 here. Ooh. Oh. Yeah. Yeah, this definitely should not be index plus k. Suffix here. It just needs to be longer. Maybe this should be n plus k, maybe. Okay. Okay, 1, and then -1. That's right. 3 plus 1 is 4. -4 plus -1 is -5. So it's the sum of, yeah, this spot and then every k spot after it. And that's the kind of that would be the maximum, or that would be the, wow, that's not going to work, is it? That would be the benefit of including every single k block after it, but that's not necessarily what you would want to do. Because if the last block is, let's say, a negative million, then you want to remove that negative million. So maybe it should be a minimum of that plus or 0. If the value is positive, then use the positive value. So the bigger of the current value, and 0, or bigger of the current value that's 0. If it's bigger than 0, yeah, so this is just appending the wrong value here. I think it's going to be the maximum of not including it, which is 0. Its current value, which doesn't include anything else after it, or the value plus the stuff after it that's at least non-negative. I think that's better. So here it's just 0. Yeah, because you wouldn't actually include the -1 block if you didn't need to. And here's 3 and 1. Yeah. Okay. In which case you could just wait, and then I think you just take the maximum, right? You just take the maximum of the array at that point. Maximum possible subarray sum. Okay, this one's wrong. Oh, because this one gives you 0. Okay. Yeah, you just can't do nothing for every single one. So if it gives you 0 at that point, then you just take the smallest. Actually, let me think. If it gives you 0, then it's possible that there were all negatives, in which case you would just take the smallest. No, you can't take the smallest negative. Can't take the smallest negative, right? Fuck. If it gives you 0, then you need to take the let's say it's possibly the maximum of the suffix, but if this is 0, then I think you take the maximum of the subarray sums. The subarray sums include 0. Like, no, it doesn't include 0. I have a feeling this is logically incorrect at some juncture, but there's a possibility that this is right. I need to comment that out. Okay. Well, unoptimized for sure. Let's go ahead and see how much the print slowed things down. Yeah, this feels like it should be doable and maybe a sliding window technique. Okay, 90. Actually, that's pretty fast, huh? Yeah, this should be doable. A sliding window technique, I would say. So look at the subarray sums. I don't think you need the suffix thing, or there's a better construction of the suffix things. You do need to create the subarray sums to do the comparisons. You do need to make the subarray sums to do the comparisons. So you'd have so if it's a positive value for your subarray, then you either extend it, and then you, let's say the subarray sum of k values is positive, then you would extend it if you see another positive, or you see a negative that is still keeps the subarray sum overall positive. Okay, so I think maybe a better construction of this would be, and there would be k different slots for that. There'd be k different slots for that. I think it'd be something like what would it be? Well, it'd be k different slots, but then you need to keep track of you need to keep track of the resets. So maybe you still need a prefix, but you need to have an array that's still n length. Yeah, so if I do this in a prefix way, let's say prefix is going to be 0. I don't know if it should be 0, to be honest. It might be negative infinity. If I do it negative infinity, then maybe that's a better starting point. So you either extend or no, I think it should be probably 0. Not sure. I mean, this is probably fine enough as a solution, but I think maybe it should be better done as a prefix just to make it easier for the logic. So it should be something like for every index in range n. I can see why I do n plus k, because then I can do subtraction of the indexing and not worry about out of bounds. Oops, n plus k here. Yeah. So this is just a reverse of the thing I previously did. So I'm going to look at extending the previous window. So if So if this is treated as the k-1 block, or the kth extension, then it would be something like the previous block would be at subarray sums of index minus parentheses k-1. No, it's index minus k. Yeah, index minus k. And then if that previous is bigger than 0, then so what do I put in here? I put into the spot a 0 if I choose to exclude it. So I think it's going to be prefix at this index is equal to the maximum of either 0 if I choose not to include it. Current value, which is going to be subarray sums at this index. The current sum, or the current sum plus the previous sum as an extension. Okay, I think that's it. And then I return if the so possible max is going to be equal to maximum of the prefix sum now. If this possible is equal to 0, then return the maximum of the sum of the individual things, because it might be negative. Else return the possible max. Doing this in this way to not recalculate the possible max. I think this should be the same, or this should be still correct. Good old out of bounds. This goes out of bounds. Oh, whoops, this is previous, should be prefix. Still go out of bounds. Subarray sums at this index. Oh yeah, so this should be, I think it should be n minus k. Or this should be sublength, actually. Which is the same thing as, I think, n minus k. Misspelling. Subarray sum, subarray sums. Sweet, sweet, sweet. This should be slightly faster. Yeah, it's the same thing, I guess. I guess it's mainly cosmetic. Feels like it might be. I guess this is just a backwards traversal rather than a forwards traversal with the prefix sum. Okay, cool beans. Still maybe off by a factor of 1 from the fastest. I guess maybe the construction of the subarray sums is what's maybe slowing it down. Can I do it without construction of that? Maybe. Yeah. I do. Yeah. So I'm constructing a prefix array and also a subarray sum subarray, or subarray sums array. So I think maybe I could keep track be pretty minor. It's pretty minor. Yeah, I think this is good enough. Okay, so let's wrap this up here. So this thing right here is just sliding window construction of the subarray sums. So add to the window on the right, append the current window sum to the subarray sums array, remove the window from the left, remove the value at the left side of the window, and yeah, I guess this is the prefix sum. Okay, so summary is to ease computation, create an array that will track for every index the sum of the k size block of values starting at that index. So like what was it? Maybe I shouldn't have deleted what I just deleted. So if the array was the array and k is equal to 2, then it'd be from the first two, sum of the first two is going to be -3, the sum of the next two is going to be -5, the next two is -7, -9, and consider that for any block, for any subarray, it will extend with the addition of the subarray sum for the next, for index equal to either index plus k or index minus k from current. So technically, if you start at index 0, k is 2, you could possibly include the next ones, k, adding this block starting at index 2. So therefore, you could add -3 plus -7 and get -10, or you can just keep it at -3. So at any, so with so iterate over indices of subarray sums. Array at any point either say that the best subarray sum at that index is the maximum of 0, which means you basically don't include anything. The current value, current subsum, or the current subsum plus the previous up to that previous k away. So in theory, if you're at index 2, you can include this thing, which is -7. You can just straight up not have anything, so 0, or you can do -7 plus -3 and get -10. But obviously you wouldn't want to do anything, so get 0. That's probably a bad example, but if it was something like this, so raise that k equals 2, the subarray sums is going to be -5 plus 1 is -4, 1 plus 2 is 3, 2 plus -3 is -1, -3 plus 4 is 1. So iterating over this -4, well, yeah, you just don't want to include that, so you have 0 over there. 3 is 3. You want to include that. -1 can be -1. You can not include it. It would be 0, or you can do -1 plus -4. The best previous, or this would be 0. So you'd be -1 or 0. Don't include it. Then this one would be 1, 0, or 1 plus 3, which is going to be 4. So this is, call this last array prefix. So prefix -4 is going to be 0, -3 is going to be 3, -1 is going to be 0, and then lastly that's 4. And then return the best prefix sum found for the, but if the best is 0, then this could mean that you rejected everything because they were negative. In which case, return the best single subarray sum. So return the single k block that is the least negative. Yeah, so maximum of the subarray sums, or the possible max here. I'm going to delete x. Alright, time complexity, this can be O of n, where n is the size of the array, as you need to compute the subarray sums and the prefix array that gets the answer. And then space complexity is going to be O of n to store the subarray sums and